All right. Hello, everyone. Welcome back to another ASP.NET Core Community Stand-Up, where we discuss the latest updates to .NET web development. I'm Daniel Roth. I'm the Principal Product Manager for ASP.NET Core on the .NET team. And today, I'm joined by a whole crew of API experts. We've got Mike Kistler here, Principal Product Manager on the ASP.NET team. Mike, you want to say hello?
Hello, everyone.
We also have Safia Abdalla, Principal Software Engineer on the ASP.NET team. Hi, Safia.
Hey.
It's great to have you back. And of course, last but not least, we have the Damian Edwards, Principal Architect on the ASP.NET Core team. Welcome back, Damian.
Thank you, Dan.
Damian is actually the grandfather of the ASP.NET Community Stand-Up. He was the one that started all of this back in the day.
When did the grand get added, Dan? I didn't consent to this.
That's your official title. So today's topic is we're going to be talking all about minimal APIs and why you should be using minimal APIs, and maybe have a little discussion about why you might not be. But before we get into that, we've got to check a couple of things. Let me share my screen here for a second. Let's take a look. We're mashing on the refresh button. It hasn't happened yet, but if you're like me and you just sit around watching, NuGet.org to see what packages have been uploaded today, you may have noticed that some preview 6 packages for .NET 10 have started to show up on NuGet.org. So it is happening. The bits are going live right now. They will be hopefully announced and available for you to download and try out later today. I've got the discussion announcement on the ASP.NET Core repo queued up and ready to push out as soon as the bits go live. So just keep hitting the refresh button on the .NET blog, and you should see that announcement going up shortly. Hopefully, by the time if you're watching the recorded version of this stream, should already be there for you to give a try. All right,
Nice.
so that's coming soon. Get excited. But for today, let me remove my screen back. There we go. Today, we're going to talk about minimal APIs and how you can use them in your .NET applications, why you might want to use them, what's their background, what's their history, what are they for? And Mike, you're here to tell us all about that. Mike, what's...
No, I'm here at least to kick it off. I'm here to kick it off. Right. So we've been working on minimal APIs for several releases now. And in .NET 10, we added a key new feature, which is the validation framework for minimal APIs that lets you annotate your classes and your parameters with restrictions, validations, if you will, validation attributes, so that we'll perform those validations for your app before we give you your endpoint control. Previously, you would have to do all those validations yourself. You would have to write those in code. Now you can just use the annotation and we'll take care of it for you. And this was a feature that was available in controllers, and I think lots of people used in controllers, and now we have that in minimal. And with that, we think that we're pretty much at feature parity between controllers and minimal APIs in terms of functionality. But there's also a lot of features of minimal APIs that make them a better choice for a modern web application. And we think that if you're starting a new project, you should really be considering starting from minimal APIs rather than reaching for controllers. So that's what we're going to talk about today. We're going to talk about what some of those advantages are. We'd like to hear from you in the chat, and we'll talk about this in a little bit. What are your hesitations with using minimal APIs, or what do you like about minimal APIs? This is just a general sharing about the topic today. As Dan said, we have Damian and Safia here who have been driving the minimal API story since .NET 6, and we're going to hear from them about some of the great features of minimal APIs. So I'm going to turn it over to Damian because Damian, you were here kind of from the beginning of minimal APIs, built the story to motivate them. So maybe you can tell us a little bit more about that.
If I could just interject real quick, I got to say, based on the comments so far, people are interested in this topic. People are asking, when should I use minimal APIs versus controllers? What's the real purpose of them? That was one. And then there was someone else asking again, why shouldn't I use controllers? Should you not use them? All these are, I think, are questions that are top of mind for our audience today. So this is great.
Yeah. Yeah, thanks. So this is interesting, right? Because I think one thing we should get out of the way up front or acknowledge out front is that the 4 people on this call are all individuals and we all have our own personal opinions about this stuff as well, and about how strongly the product team should or shouldn't recommend one thing over another. And I think that extends into the ecosystem as well. And that's just kind of like part of being a developer. Like, people like to argue about why you should use one thing over another, or discuss trade-offs, which is what it really is all about. That's really what we're going to talk about, is trade-offs. It's not really about one is demonstrably better than the other for all scenarios. They're like, it's almost never the case that that is true. And in the case of MVC or API controllers specifically versus minimal APIs, there are things that each of them do well subjectively, again, like depending on what you value. But, you know, to Mike's point, like the way Mike phrased it is that the team does feel that the minimal APIs offering is a more complete modern offering. Does that mean it's better? Well, that's something for pundits to argue. But where I think today we'll highlight some ways that we think minimal offers a bunch of advantages over controllers, without necessarily telling everyone you should all stop using controllers and, you know, obsolete all your API controllers and rewrite them to minimal. That's not what we're saying, right? But I do think it's definitely worth us talking more about it. So if we kind of like rewind all the way back, I'm repping my ASP.NET 6 t-shirt today that Safia designed, which is when we launched minimal APIs. Why did we do this in the first time? So I wasn't on the minimal crew from the very beginning. At the very beginning, it was Maria, who was a new PM on ASP.NET Core at the time, and Fowler, right? Before he was a distinguished engineer. He was just a lowly partner at that point, I think. So he
very non-distinguished.
yeah. So Maria was bringing a perspective of, hey, as someone who is new to C#, but is familiar with other stacks that offer API, you know, web API or HTTP API capabilities, the ASP.NET Core stuff looks kind of complicated. It looks like heavy. There's a lot that you have to learn before you have to get to, you know, building what it is that you want to build. And then at the same time, as folks who will know if they've followed us with .NET Core all the way through, we were keen on performance, and we were looking again at what can we do to improve performance a little higher up the stack. We had done a lot in Kestrel. We had done a lot in the middleware pipeline. We had done a lot in the, you know, the BCL and the .NET runtime that we sit on top of. And so we were turning our attention to some of the higher level things like, hey, you know, what about routing itself? What about the MVC and the API controller stack? What can we do there? And those two things kind of collided, like they kind of happened at the same time. And as a result of that, Fowler did a whole bunch of sort of investigation into what can we do to make MVC faster? How can we make it more pay for play? So pay for play was one of these axioms that we kind of threw around at the beginning of .NET Core, which is if we're going to rewrite the stack from the ground up, which is literally what we did for ASP.NET Core. We started with a blank project and we wrote brand new C# for everything in ASP.NET Core when we started. How can we make it so that you only pay, that is, you only have to exert computing resources when you run your server for things that you're using? And that was something that we worked really hard on, because it was very much not the case with System Web and the older ASP.NET stack, and even MVC sitting on top of that. There was always a cost associated with even doing Hello World over there, just because of how that system was architected and kind of the legacy associated with it. And so as he looked more at MVC, he kind of realized that the reality is, given the way MVC is built, and specifically why it's built that way, what it enables, like all the little hooks that you have and all the interception and extensibility points that the MVC execution pipeline brings with it, means that there are these many layers of like indirection and decision making that occur as you're moving through the pipeline. And that's not necessarily on its own a bad thing, or even a thing that causes performance issues. But when you make each of those things pluggable and they're dynamic such that they can change at any time over the application's lifetime, it does drastically reduce our ability to do things like caching well. Because it means that basically at every time we have to make one of these decisions in the pipeline, say, hey, has this application customized this specific aspect of MVC? It wasn't enough to even cache what that lookup, for the current HTTP connection and reuse it for each request. It might be that you're doing dynamic discovery of like, which company is this request for, because I'm doing some multi-tenant type of situation and I'm doing that plugging in via the dependency injection container. That can become a lot more expensive than just calling a method that returns something, obviously. And it means that even if you weren't using all of that capability in MVC, the flexibility in the pipeline to do a lot of those things, you were still paying for them a lot of the time, because it was just not possible for us realistically, A, to maintain compatibility, but B, to kind of further optimize that pipeline, just because of all those capabilities. And so,
And if I might add,
yeah,
because you shared that really interesting thought, Damian, I think another benefit of having um, implementations that are like less customizable, which maybe someone might perceive a con of that, is that there's less flexibility. But one of the positives that comes really well into minimal API strengths is it makes it a lot easier to do things like support native AOT compat. It makes it a lot easier to build APIs that are a lot more like diagnosable and understandable. Like this is a value prop that I've been presenting a lot for minimal APIs. It's just there's less stuff going on and less customizable pipelines you have to reason through. So it's a lot more straightforward to reason about why is this binding happening a certain way. I think one of the interesting ways I see that kind of come up when I interact with users is I actually have an intuition that when people report bugs on GitHub related to minimal APIs, they're able to do a better job of reasoning about why a certain bug is happening because they kind of understand a little bit more about the parameter binding that's going on in minimal APIs based entirely on the stack trace than they would for the same kind of issue in MVC. So I think that that is one of the big kind of design distinctions between MVC and minimal, and ends up having all of these like trickle down effects as we kind of talk a little bit more about how minimal evolved.
yes, absolutely. Yeah,
Yeah.
absolutely. I think Hanselman is the one who I know at least, who coined the idea of if you do nothing, you can scale infinitely. And so if
Yeah.
you do less, you can do more of it. And I think that helps not only in the performance case, but obviously in the case that you just highlighted, which is just understanding like what's going on and
hmm
what happens in the failure mode. If something is not working correctly and I have to diagnose it, how complicated is it to understand all the bits that came into making it behave the current way, if that's not what I want to do? And so based on that kind of adage, and then at the same time, this simplification effort. So this question of like, how can we make ASP.NET Core and writing APIs more approachable to people who are new to the stack? Given that MVC was, frankly, shipped in the late 2000s. Like we did the first preview in 2009. And then when we moved to ASP.NET Core, we quite literally picked up the MVC framework as it existed over in the world of .NET framework, and we ported it on top of ASP.NET Core. And it wasn't ever really natively integrated in such a way that ASP.NET Core end to end had like a new app model that was all the way through. It's kind of hard to articulate, but I always felt like MVC was bolted on to the end of ASP.NET Core rather than ASP.NET Core absorbing the parts of MVC and then kind of reusing them. We never actually did that work. We talked about it. And there were little things that we did along the way, but we never fully did it until we did minimal. And what I mean by that is things like routing. Like we kind of routing when we first brought it over in ASP.NET Core worked a very particular way, this old conventional routing system, up until ASP.NET Core 3, when we introduced endpoint routing. And MVC was built on top of that. And that routing worked that way because that's how we wrote MVC in the end of the 2000s. And it had a whole bunch of trade-offs associated with doing it that way. Things like the filter pipeline. So the ability to add methods that get called in line before your action method, and then conversely on the way out as well, so that you can look at the result before it's executed. That was all in MVC. None of that was in ASP.NET Core itself. It wasn't a native construct of ASP.NET Core. All ASP.NET Core had, all ASP.NET Core had was like there were servers, there was a middleware pipeline, and that's it. Like that was literally all we shipped ASP.NET Core with in terms of request processing primitives. And it wasn't until we did minimal that we extended that with what we actually had as the initial vision for ASP.NET Core, which is what do we think a modern request processing pipeline would look like?
Yeah.
And so
breaking up the monolith.
Yeah, exactly. Yeah.
Yeah.
And so we're actually now, I think since about .NET, I think really with .NET 10, I guess, with the addition of the validation support in minimal, we've really, I think, reached a point where we feel that the minimal APIs kind of offering is somewhat complete in that it has all the things that you would want, and it utilizes the things available in the BCL, like validation, and then plugs them in for you. Whereas before, some of those things were missing, especially when we did .NET 6, and then we did a little bit more. We introduced filters in .NET 7, and then in .NET 8, we did native AOT, and then in .NET 9, and so on and so forth, right? And so it's taken us a few versions to build it out. But like we rewind back to the beginning, like I said, Maria turned up and said, hey, like, can we make this simpler? Look, I'm comparing it to these other stacks, and this looks far more complicated. They actually went out and did user studies. And so Fowler like wrote this prototype of what could a new sort of coding model look like for ASP.NET Core. And it didn't just include the API stuff. It also included the boot up stuff. So we had the startup class and all of those primitives before. He kind of rethought a lot of that, which has now become the web application builder. And they did user studies. They like invited people, they wrote docs, they invited people to come and look at this site that wasn't the Microsoft site. So, hey, there's this new web stack, this new API stack. Like, can you try writing something in it? Here are the docs, and like, tell us what you think. And then we would compare that and contrast it to folks who are asked the same thing, but were given ASP.NET Core with MVC. And that the results of that really encouraged us as this was worthwhile doing. Like, obviously it's jarring to an existing ecosystem whenever you introduce another way to do something that largely just isn't compatible or the same as the existing way. But we felt it was worthwhile given what we saw out of that user study. And then on top of that, the performance benefits we saw were also massively worthwhile. And so if we were going to build a new API stack from the ground up, how did Fowler put it? He said, we only want to write the code that you would have written yourself if you were just writing this as a middleware. So if you were just going to like say, hey, I'm going to write an API endpoint that accepts a post and takes some stuff from the query string and the form body and then returns some JSON, and I was going to do that raw, like vanilla, no framework, but in ASP.NET Core, what would that code look like? And so we wrote that code literally, and then we said, right, let's build the reflection-based code emitter that writes that code for you based on if you just declare a method that looks like what you want the input be and the output to be. And that was kind of our guiding principle. And I think, Safia, you wrote a lot of that code, the code that looks at your method, your endpoint handler, and then generates the actual code that runs behind the scenes based on that. And then, in .NET 8, we did it again when we built the native AOT support
via source generator.
So you built a lot of that code. So maybe you can talk to like that principle we had of like, we really just want this to look like the minimal amount of code you would have written to make this work.
Yeah, I think taking a peek at actually with the request delegate generator, which we introduced in .NET 8, if I'm recalling correctly, emits by default. And that's probably like a great way to take a peek under the hood at exactly what you were describing, which is all of the code that we're generating is basically examining the HTTP context that is emitted by your application, trying to get a sense of how it should bind or resolve the types that it discovers in your route handler based on what's in that context, and then doing some serialization to the response using system text JSON in our existing HTTP response APIs. And we can actually take a look at what that code looks like because it's fairly easy to read. And if you're not familiar, source generators and like the outputs they emit are super accessible to you as a developer. If you run your ASP.NET Core app with publish AOT enabled, which for minimal APIs actually lights up a ton of behavior for you. There's this flag you can pass, emit compiler generated files, which is major cheat code if you are somebody who, like me, finds themselves writing source generators an awful lot. It's a great way to take a peek at what is going on under the hood for like a typical a typical source generator. So let's take it like an example of what this code actually looks like. And I
Does
think
someone
that
want to
gives
share?
us,
Does someone have
yep.
who's so do Mike's code, or we?
I'm going to be sharing my screen. Super
Okay,
fun.
perfect. While you're doing that, there was some interesting questions about the naming here of minimal APIs. If those minimal APIs imply that there's an existence of maximal APIs.
Yeah.
Maybe we should
Yes,
speak a
it
little to
implies
why
the
we called it that.
existence. It implies the existence of maximal APIs, also Scandi, Japaskandi APIs, 60s, mid-century modern APIs.
So it's minimal
Anything.
in the sense of the
Yeah,
amount of code you have to write to
yes, the
build an API
minimal
endpoint.
is about the low ceremony. It is not about the lack of power or functionality in the APIs. There have been many a debate about whether that name was the right name to go with. Should it be renamed to get all of these things? But the thing about names is you only get one chance to name something, and then it kind of sticks, and you have to live with it. But no, minimal does not imply any weakness
So
on
low
behalf
ceremony,
on the framework itself.
low architecture overhead, like Damian, you were talking about how this sits lower in the stack, closer to
Right.
the metal in some sense, so you get better performance. So I guess maximal performance in that sense, minimal overhead. But I think it is fair to say that early on with minimal there were some feature gaps, so there was a little bit less feature
Absolutely.
complete than the API controllers. I think what we're saying now though is that that's really not the case. Like particularly with .NET 10, the vast majority of any functionality gaps have been filled.
Right. And but I even just to touch on that, like that depends on your perspective. So we have a lot of customers who use alternate validation frameworks rather than the one, like a lot, rather than the validation that's in ASP.NET Core itself or the BCL. Like Fluent Validation is a very popular validation framework. So saying it was incomplete simply means, or feature, there were feature gaps. No, we didn't hook up for you the base class library's concept of a validation attribute to the minimal API's execution infrastructure, like we did in MVC, for example, and Blazor. But it was quite trivial for you to do that yourself, right? Because again, in line with the principle, it was like, well, the point was we were stripping back a lot of the layers, stripping back a lot of the ceremony, and just letting you write the minimal amount of code, the very clear code that you would do in order to get your API to work. And when we looked at these other stacks, like part of the effort Fowler did initially was to go off and do a bunch of like ecosystem analysis on other stacks. And he had kind of that moment as an architect where you've looked at, dozens and dozens of different things, and you just distill it down into, well, these are the 3 patterns I saw. They were all just revs or iterations or variants of one of these 2 or 3 patterns. And one of those patterns was very much the pattern that minimal is based on. So if you think of something like Express.js in the Node world or Fast API in the Python world, et cetera, they all look fairly similar. They have this idea of a delegate, and you have a route that goes through, and you get like parameter binding from that method that you invoke. And that's kind of it. Like they don't really have a lot of higher level constructs. They assume that you're just going to call helper methods to do things like that, or you'll plug in a piece of middleware that'll do that stuff for you.
But is that because they just weren't as good? They just weren't as cool as we
and
are.
I will go all the way back to what I said initially, is that I'm not here to cast judgment on what is good or not. I'm here to show you what each can do, and then you can make the decision for yourself as to what sort of trade-offs you want to make.
And I actually think one of the key value props of minimal is that extensibility. In my personal perspective, as like a framework designer person, I don't think having everything out of the box is necessarily the best approach. Sometimes it is good for things to be incomplete so that there's spaces for like innovation or extensibility in other avenues. And I think one of the other things is like we as the ASP.NET Core team have opinions about how things that are built into minimal APIs should be implemented. So, we have validation support now. We can dive a little bit into how that works and some of the interesting design points of it. But the fact that you are able to also build alternative validation solutions that might have a different shape or approach is like a good thing for an ecosystem and a platform. So I think that's key to call out as well.
Give some nice flexibility.
Yeah.
Brian was asking also, like you were talking about features that you might have to do yourself. Like Brian here, it looks like he was asking about like formatting, like if you want to do content negotiation style things inside of minimal. That's probably something I assume you still have to do yourself. I think we just basically do JSON in minimal APIs. Is that right?
So our default is JSON, but one of the things I did as kind of one of the product architects, as I like to call myself, who came in to minimal after it started, was that I sat in the seat of the customer and I was like, okay, how could I do things like content negotiation, if it's not provided to me by the framework? How could I do things like custom parameter binding if it's not something that has a whole pipeline and DI thing and like all the stuff that we do in MVC for that? And I focused on try to build those things as the end user, and then identify gaps in what we're doing or blockers in what we're doing in minimal, so that we can fix those. And Safia probably remembers a lot of my contribution was just like, look, I did this ridiculous Rube Goldbergian type of thing over here, but I was blocked by this part of minimal. Can we just like loosen that up a bit so that I can plug in here? And I shipped a bunch of that as, you know, a NuGet package called Minimal APIs Extensions, which enables you like a bunch of helpers basically that you can plug in that will enable you to do kind of more complicated stuff, even though minimal itself is quite simple. And so I think that speaks to Safia's point, is that if you strip stuff away and do less out of the box, you actually create more flexibility in some ways, rather than trying to architect explicit extensibility throughout the entire thing in the beginning, which is more what happens with MVC. And so with frameworks like MVC over time, what we saw was that you would get lots of requests from customers from release to release saying, can you add a hook for X? Can you add an extensibility point for Y? Because they, even though because it was a large sort of layered system, there were parts of that system that were like opaque boxes. So like once the request went in there, you just had to wait for it to come out the other side, and you didn't get to do anything in the middle of it because it was doing so much. And then over time, we would have to chip away and add more hooks on top of hooks on top of hooks in order to enable the type of things that people wanted to do. And that adds weight, in want of a better word. Like this, it's just difficult to do that and keep the system streamlined and pay for play, like I said before. So if you do less, turns out you can do more.
You could do
in lots of
more.
different ways. Yeah.
So minimal APIs are actually maximal APIs. That's the theorem.
Two sides of the same coin, maybe. Yeah.
Just real quick, for people who are asking about like choosing between controllers and minimal APIs, I just want to make sure people will know about there is a doc in our doc set that addresses specifically this topic. If you just look in the ASP.NET Core docs under the APIs node, you'll find this overview topic, and that goes through like when to use minimal APIs versus controllers and what some of those trade-offs are that Damian was referring to. This link should be included in the URL list for the stream today, so you can find it there as well. All right, Safia, should I go ahead and share your screen?
Yeah, I can very briefly show it because I think we want to get into some of the interesting questions about structure and why are these people telling us to put code in one giant big mega file. Okay, so this is the output you'll see from the minimal API source generator. This is actually a good way to understand what code both the source generator at compile time and the reflection-based implementation at runtime are emitting, without having to look at a bunch of reflection code and link expressions, which can sometimes make me cross my eyes a little bit. But if you look at the structure, it is like pretty basic. You have a request handler, which follows like the canonical request delegate shape, right? It takes an HTTP context and returns a task, and you can implement the core functionality of your API here. And this is kind of the behavior I was telling you before. We try and examine your route handler, and we figure out, okay, are they trying to pull something from the query string in the request? Is this something we can bind as a string? We'll do all of the binding here, and it's pretty like structurally consistent code. Where is this value coming from, or where do we think it's coming from? Because I think one of the kind of interesting things about minimal API when it comes to the binding layer is we have a lot of built-in inference rules where we will try to say, okay, if you've provided us a argument in your action that is like a value that we can parse from a string, it's probably going to come from the route or the query string. So we'll try and figure out which one of those it is. And obviously you can use the attributes to clue the framework in on where things should be bound from, but some of that magic is implicit. and you can kind of see how those rules get constructed here. So it's very like structurally straightforward code of here are all the arguments the user wants, P1 and P2. We're going to try and resolve them from the HTTP context. If that resolution and that binding was successful, we're going to call any their core handler and also any filters that they might have registered in their application, and then return what was the result of that request by calling into the serialization APIs. So that is literally it. Like the core structure is bind, call, return, and return is like write the response. And you'll see this pretty consistently in all of the code that we generate. Super easy to understand, even if you're not a like an expert in reflection APIs or frameworks or anything like that. So I think that's a great way to demonstrate just how simple some of what's going on under the hood is.
Cool. Yeah. So the
Now,
fact that this code is generated on the fly, I'm guessing a lot of people aren't even aware that's happening, how these things get
yes.
wired up together.
Yep, if you've got, and one of the cool things about the source generator implementation is that the debugging experience is a lot nicer in source generated code because you can actually step into the code that I just showed you as you're debugging your API. So you can like see where things are happening beneath the scenes. You can't do that as well with some of the stuff, the code that's generated dynamically in the non-source generator implementation. But that's kind of another small perk of minimal APIs, especially if you use RDG, you get really nice step into debugging on the actual framework code that's generated for you.
I've got a bunch of questions about like organizing your minimal APIs and structures.
Yes, the elephant in the room.
Yeah, you have a big project or a big application, lots of developers working on this. Do minimal APIs really scale up to that level of product development?
So I have a way of talking about this that I think maps to how we were talking about it internally when we were designing this. So if we think back to what I was saying about, we were comparing to other stacks. We're thinking about what's the onboarding experience like for a new user? Like, how do we avoid disclosing a whole bunch of concepts to people when they're just learning before those concepts have any utility for them whatsoever? What we realized is that you ultimately want to be able to, there's this balance between leveraging aspects of the language involved, so in our case that's C#, versus leveraging the type system and the specific types that are available to you in the framework. So if you kind of think about positioning, there's features of the language. So C# has constructs like, functions and lambdas and variables and method groups and delegates and classes as a construct, et cetera. But then there are constructs of the .NET framework itself. So you have various types in namespaces that are shipped to you, and those types have behavior. So those become the constructs that you use. And very often before core, the way that you would use something built on .NET is you would say, hey, you derive from this type, we give you a base class, and then there's a whole bunch of virtual methods that you override in order to implement or adjust the behavior that you want to. And there were a lot of reasons, a few reasons for why things were done that way. Part of it was just the OO centric nature that .NET was originally created under. And obviously we know over time C# and .NET has evolved to not just be pure OO, but to also borrow a lot of functional concepts as well. But also .NET relied very heavily on tooling in its first half of its life, in its first 10 years, I think it's fair to say. And so a lot of the coding experiences were often IDE designer experiences, in the sense that you would use tools that were visual to generate code behind the scenes. And then that code would be introspected on later at runtime or by other tools to generate more code or to do, to perform certain behaviors. And when you build a system that way, it leads you to using constructs and architecting it into a certain way that is a cost, right? Because you're trading off perhaps runtime performance and memory use and things for a certain developer experience that you're building for. Now, the developer experience that we were targeting with Minimal was very different, because when we looked around the rest of the programming world at that time, and even today, although with AI it's changing a bit, but like we won't go there at the moment. there was really a focus on just, I want the code to be easy to read. I want a bare set of primitives available to me, and I want, don't give me a heavy set of layers to sit on top of. Just give me things I can compose with as I need them, that whole pay for play thing, so that things are easy to understand and I only pay for them as I need them. And so that led us to decide, hey, one of our design principles for minimal is let's utilize language constructs over framework constructs. And what you may recall is that when we did .NET 6 and we introduced minimal, a whole bunch of new things showed up in C# as well that minimal used. And that's because we were working really closely with the C# language team to enable the coding experience that we wanted. We said, hey, we want a method that accepts a lambda, but we want the lambda type to be implicitly inferred. We don't want you to have to declare the return type and declare. And they were like, oh, that's like a whole feature in C# to do that. So they did that for us. And then in .NET 7 and .NET 8, when Safia was doing the native AOT support with others on the team, we were like, oh, like source generators are great, but we need these other kind of features. And so a whole bunch of stuff came out of that as well.
Right.
And so we've really lent on trying to enhance the language and enable core things like building blocks in the language that then let us build the coding experience that we wanted for customers. So that's another way of thinking about the two frameworks. Like MVC is very similar to like traditional .NET, where you declare a class and the class gets activated and it has a contract and a life cycle, versus minimal is literally a method. Like from the point of view of, it's much more in line with the rest of the ASP.NET Core request processing pipeline. Middlewares aren't classes in the traditional sense that we might think of. We don't new up your middleware on every request because that would be expensive. The middleware, typically, if you do implement it as a class, is instantiated once at the beginning of the application or the first time the middleware is used. And then we just call a method on it over and over and over again. So they are shared. They are singletons by design, because that turns out much faster and scales much better than creating lots and lots and lots of types every time you create a request. And so that's one of the ways that we improve things there. So the thing is, like, we're more code focused. So bring that back to structure. What are the features of C# that let you structure your code? Well, there's lots of ways you can structure code in C#. Like, you don't just have loose lambdas everywhere. Lambdas typically or method groups get declared or passed in somewhere. And so you can put those in places, that don't necessarily look like the hello world example. And so while we may not have declare a class and then we automatically find that class for you, and then we create it using the DI pipeline and all the rest of it for you, you can absolutely put your minimal API endpoint handlers. They're just methods. So they can be delegates, they can be lambdas, they can be method groups, but they just have to be a method that you can pass in, that can be invoked in isolation, passed into the map get call or the map post call that you're putting on the endpoint, sort of this wire up logic. So as long as you structure it in that way, you can do anything that you want to, really.
It might help to see some examples of this, but Mike,
I've got an example here actually to show of exactly this. This is the eShop application that's in the .NET GitHub org, and this is our sort of showcase API application. We've been maintaining it since .NET 8. We're going to be updating it again for .NET 10. But in there's a bunch of microservices in here, and one of them is the catalog API. And you can see that this is an API application that has structure, but it is a minimal API. Okay, and we put all of the API endpoints in a directory called APIs. Then there's a models endpoint where all the models go. There are integration events. There's a separate directory for services. You can put data in here. We have all of our pictures for the catalog in here. So you can put whatever structure that you want in your minimal API, and it's very amenable to that. And just to dig in one level deeper, this is the catalog API file, okay? And here's where we put all of the APIs for the catalog. And if our minimal API had different endpoints that it was serving, you could create a separate file for this, much like you do for controllers today, right? You could create as many of these endpoint files as you wanted and put them all, organize them all in an APIs file or an endpoints directory if you wanted. And the way that this looks here is we have a static method that will do the map calls for all of our endpoints for the catalog API. And you can see we add the get all items and get items by ID and all these different endpoints. And then those endpoints are defined with a static method that's defined further below. Okay, so here we have our get all items, and we put the code there. So you can have your endpoints defined as methods, and then you just refer to them from your map endpoints. So you can put structure in a minimal API. You can put whatever structure in it you like. If you like the controller's structure, you can reuse that if you want. So this hopefully shouldn't be an impediment to adopting minimal APIs.
So that allows you to like group a set of API endpoints together, like using a class as a way to, with a method where you just add all the related endpoints together. Controllers also, though, like there's an object there, right? Like there's an instance with some state. Like how do you deal with that in minimal APIs? Like what if you have a bunch of endpoints that all need like the same DI service or something like that? How would you handle?
Right. So we actually handle that. There's another example of that here. Again, in eShop, where we pass in the things that normally would have been injected in the constructor for a controller. You can pass those in as parameters to the methods, and you can group them so that you don't have to have all these things repeated in something like catalog services. So here's this catalog services.
Probably under the services folder.
Yeah, thank you.
I think it might be under model, actually.
I think it's just in the same file. Is it? Or is it in models? Oh, there we go.
Yeah.
There we go. Yeah.
Who's the schmuck that wrote that? I'm the schmuck that wrote that, so I can make fun of myself.
So here's where we have all of our objects that are injected into the methods, and we simply define them in a class here, and we populate them into the DI container, right? And then using as parameters, we can specify these catalog services, and we can get access to them in all of the endpoints.
Yeah, that makes sense. So you can just have like a common parameter that captures the same set of things that a bunch of API endpoints all need, and you just pass that one parameter object wherever it's needed.
And the key part is the binding rules that Safia talked about before, the code that gets emitted that actually populates these things. The rules are exactly the same as if each one of these were a parameter in the method, or if they're properties here. That's why it says as parameters. That's why it's called that, because we literally just look at the members on the type and they just treat each one of those like they were a parameter to the method. So it is an organizational construct here. It's not a state construct like you're alluding to, Dan. But and honestly, we haven't had a lot of requests for I want to utilize something with shared state, because in a web application, in the case of a controller, for example, each action method only you only invoke one action method per request. So any state that you initialize in the constructor, for example, is only useful for that one method anyway. It doesn't persist beyond that request. And so you don't actually get an awful lot of state sort of encapsulation and reuse and whatnot, or lifetime out of a controller, because it is a class. In fact, in the ecosystem, you'll see a lot of our MVPs and other influencers advocate for slim controllers instead of fat controllers, because often you'll pay a penalty by grouping lots of action methods on one controller, where each request only invokes a single method, because the constructor will have to run every single time. And often it's very easy to fall into the trap of the constructor performing logic that's only required by some action methods, but then you pay for it for every action method that's on that.
One.
Yeah. And so those things don't go away. You still have to think about here, if you're factoring things into an as parameters type, and then you're accepting it into everything, then you're going to pay for the cost of that as parameters instantiation in a method if you accept it. But I think it's a little more obvious when you accept it as a parameter to the route handler delegate, versus it's hidden away in a constructor on a controller when you're focused on a specific action method. So, but yeah, you can absolutely you can achieve the same kind of thing.
Someone did ask, like, look, can you not just use a normal DI style pattern here?
You can.
And yeah, you want to talk a little about that, Damian?
So that's what's happening here, right?
Yeah, I mean, I guess there's two things at play. There's as parameters, which is a minimal API specific context that allows you to create essentially like a binding surrogate. It says, I'm going to define a class. It's going to have some members. I want you to go look at those members and bind them the same way you would if they existed as parameters on whatever handler I'm passing. That is like parameter binding surrogate. For resolving things from DI, there's like two ways that minimal APIs does this. So if you go to catalog services again, you have the from services attribute on two interfaces, or yeah, two properties, I guess, in this class. That is a clue that minimal API uses to say, okay, I should, when resolving, doing that binding logic that I was showing you in the source generator, I should pull this from DI, instead of trying to bind this type from the JSON body or somewhere else. So the inject attribute that you are referring to here is the from services attribute that we'll use. Now, a cool thing about minimal is we were talking a lot about like implicit binding behavior. There's actually a rule in minimal where at startup, if we see that there is a type declared for one of the parameters in your handler, and it is a type that exists in the DI container, then we will favor binding it from DI over the JSON body of any requests that come in. So you could technically, if you knew that iCatalog AI was going to be registered in your DI container at startup, remove that attribute altogether, and automatic resolution from the DI container would take place when like your request actually kicks in.
Which is an example of conventions. Like that's just a conventional
Yeah.
thing that we looked at and said, hey, we have enough information to do this for you automatically. It doesn't prevent you from being more explicit with the from services attribute, but why not have the option for implicit binding as well?
Yeah.
And you get to decide. If you want to be more explicit, put the attributes everywhere. That's totally fine. Like you can totally do that.
I just realized that Marvin might have been asking why we have from services and inject attribute as like two separate attributes to signal like, hey, this should be an injected thing. And
like Blazor and
yeah,
controller. Yeah.
So, I mean, we could talk about the difficulties we could talk about the difficulties in designing. Like this is part of the issue when you don't do huge waterfall and then release only ever one release of your framework ever, right? The reality is it grows organically over time, and often things get placed in a specific assembly in a specific namespace, which affects their name and how you can use them because of the layering and the rules about what you can depend on. You can't have cyclic dependencies, for example. And so we actually hit a lot of that when we built Minimal. You'll probably recall, Safia, and we had to do a lot of work.
And we're still running into it.
We're still running into it. So
results.
like we did things that used to live in the MVC assembly might now live in a lower level assembly, but they still have MVC in the name. It's things like that because we could forward them from one place to the other, but you can't change the name in .NET. And so we were careful. Like in other cases, we ended up duplicating things. So we have an attribute or something that lives over in the MVC world, and then we have something that looks almost identical but is maybe slightly different that lives in the lower parts of ASP.NET Core. And it's like, why did we do that?
Interject, Damian, and talk about the one that I see so many issues on, and I have to like issue a public apology / PSA to the community. JSON options.
Yes.
There is an MVC version that is in the MVC assemblies, which are way higher up in the stack. And there is an HTTP version, which exists lower in the stack and actually gets used by a bunch of things. Minimal, open API support, the problem details support that is lower in the stack. So we were talking earlier about like factoring things out from the monolith. As it turns out, sometimes you realize you can't just like lift and shift things. And so there are places where there's duplication. That is where you might run into some friction as you're migrating between the two things. No, that is not coming out of malice. That is just like the reality of breaking up a monolith means that it's not a smooth transition. So yeah, that's a big one that unfortunately a lot of people run into, but for good reason.
I want to share my, I just had a graphics card glitch.
Oh, I was just about to say we had a little under 10 minutes here. Like, do we want to rip through a bunch of questions real quick, or did you guys?
I wanted to demonstrate just like visualize one extra thing using the debugger, which might help. But my browser window's literally just gone black, so I can't even see you all. So we won't do that. That's totally fine.
I was hoping, Damian, that you would talk a little bit about the performance benefits. I mean, we've been talking about how we've, taken things out of here, but and how that lets you go faster, right? But we actually have some measurements of that, right?
We do, and I have it here on my screen. I was ready to share it as part of that same thing, and now I literally can't click the share button because I can't see it. Oh my goodness, that's unfortunate. Sorry,
but they are faster.
Well, I mean, I can speak to it, and people can follow along. So there is if you go to the URL aka.ms/ASP.NET/benchmarks, that will bring up our publicly published Power BI driven benchmarks dashboard. And then at the bottom of the screen, you'll see that there's a paging indicator. It'll say like page 3 of 21 or something. If you click on where it says of and scroll to the top of the little flyout that comes up, if you click on the benchmarks page, which I think is page 3, this gives you the ability to basically look and compare at all the different benchmarks that we regularly run. Now, the ones that are interesting on the right-hand side, where it lists all the scenarios, you can control click on the different ones. So if you control click on like JSON MVC, or click on JSON MVC to select just that, and then control click on JSON minimal APIs, you can directly compare what is the performance of a JSON API, idiomatic, built in MVC with a controller versus JSON and minimal APIs done in an idiomatic way. And you can, so that's kind of like the bare maximum sort of best case scenario of how much faster in terms of requests per second, how much lower latency. All these things are plotted on here. The startup time associated with the application, the memory use, the CPU use. It said hopefully in a benchmark, the CPU use is roughly around 100%. But you can see all those other metrics and how they compare. And so this isn't, like a super stripped back benchmark. It's literally what does it look like if you do an API controller that, like is hello and returns a JSON payload, or a minimal API that accepts, goes to some route and then returns a JSON payload.
I'm trying to show it, Damian, while you're I'm on the page. I'm on the benchmark. I know you can't see any of this because
can't, unfortunately.
I'm just not showing. But like on the list of I'm on the benchmarks page on the list of benchmarks. Which one is it?
So they're on the right hand side. There's JSON minimal APIs and JSON MVC.
I see JSON MVC and JSON platform.
Are you on the benchmarks page?
I'm on the. Oh, maybe I might be on this one. This one. Okay.
So it should be on page 3 of 21.
Yeah, okay. Yeah, we're getting there. JSON minimal APIs, JSON MVC.
Yep.
Control click. Did the control click? There we go.
Yeah.
There we see some of the.
And then in the top right-hand corner, you can see the environment. So we run this on lots and lots of different machines. I was looking at it on Intel Gold Linux, which is our most modern Intel-based server. It has a 56-core server machine versus, I think it defaults to Intel Linux 28, which is our old Intel server. So, I mean, if you choose that one instead, you might see the results slightly different. But we also see in these, we run other frameworks. So there's JSON for Node, there's JSON using Express, there's JSON using Gin, which is a Go framework, et cetera, JSON Spring. So you can kind of compare to other stacks and get a sense of kind of the overhead associated.
And this benchmarking page, is this public? Like, is this?
This is the public one. So we publish this. This is a public version that we publish all the time.
So I just went to aka.ms/ASP.NET/benchmarks, and that's what brings
correct.
up our Power BI for people that wanted to replicate that. Okay, cool. All right, that's great. Thank you for talking about that. Was one of the questions I saw as well. How are we doing time? We got 3 minutes. One other question about rewriting. Should I rewrite all my stuff? I have all these controllers. 20 projects. Should I rewrite them all as minimal APIs?
No.
I mean, maybe. Depends on the trade-off, right?
It depends, right? Yeah, that's the right.
So I guess the elephant in the room on that question, like, are API controllers like going away? Like, are they gonna like disappear from the framework? Like, no, like they're in the framework. We plan to continue to support them. Are they where we are really investing and innovating? No, like our investment and innovation is really going into minimal APIs. So if you want, the latest performance improvements and the latest feature enhancements, minimal APIs is where you'll get the most future payback on the platform investments. But your API controllers will, of course, get all the normal investments from improvements in C#, improvements in the core libraries, improvements in .NET itself. So you still will be fully supported and get all those benefits. But our ASP.NET team and focus is much more on the minimal API model, just because we feel it's more modern, it's more minimal, it's less ceremony, and it's where we really think the direction is going.
Well, I would just add, I think it is somewhat equally a strategic decision because of the things that you just said, but it's also like a mechanical decision. Like native AOT is a good example. Native AOT support for minimal was something that we had in mind from the very beginning of designing minimal. And so when we came to add native AOT support, it was an awful lot of work, don't get me wrong. But it was something that we were able to achieve. MVC, just by its very nature, it's not that it's impossible to do native AOT, but it would be a much bigger lift, and it would almost certainly come with a much larger list of caveats. That is, these are things that don't work in API controllers when you compile native AOT. Just because of how it's built, just because of the type of features and the way it exposes those features to you as the coder. There's just some things that we simply cannot make work due to physics because of just the way it works when you do native AOT. And so that is both strategic and like just architecture. It's just very hard or impossible to do some things.
I think it's worth also saying that, and when we talk about native AOT a lot, and it is a design point in .NET, like we want to enable things to be native AOT-able. That does not necessarily mean that like you should go and now turn on native AOT for every single one of your apps. Like it's not a. In fact, I would think it's fair to say that a significant minority of our users actually use native AOT, but we want that scenario though to be possible and to be good and to be relevant. If you need native AOT for a variety of reasons, based on your environment, for certain performance reasons, we want that to be possible for basically all the future techs that we're building going forward. Hence the focus on minimal APIs.
Yeah, it's a different set of trade-offs. Like native AOT is never going to be turnkey. Like you can take any .NET app and make it native AOT, and it's a journey. Like the ecosystem has work to do to support more native AOT being supported by more things. Again, just kind of due to physics. But yes, we want our modern stuff to be native AOT possible. And right now, that means minimal APIs is there's still caveats. Like when you as you're alluding to, like if you choose native AOT, you're choosing to get better startup performance, smaller file size, perhaps better memory use in lieu of some other things.
Perfect. All right. I know we're at time, and I know there's a lot of great comments on the in the chat. We will try to go back and look at those after the show. So thank you for everyone, first of all, for being here and sharing the context and history and the future roadmap for API development with ASP.NET Core. If you have other things, for folks in the community, if you have other questions or other discussion points that you want to bring to the team, please come to our GitHub repository, come to the ASP.NET Core repo. We do have our discussions forum enabled there, and the team does participate in those, so we can chat with you there. If you have ideas on how we can make API development better in ASP.NET Core, go ahead and open GitHub issues and submit your proposals there. That's how you can share with us your feedback. So Safia, Damian, Mike, thank you again for joining us today. Thank you, all of you, for watching. And
thank you all
for the next community stand-up. All right. Have
Thanks,
a good one, folks.
Bye.